Before we take a look at distance formula, let's not forget what today is.
Uh-oh. Guess what day it is? Guess what day it is? Huh? Anybody? Julie, hey, guess what day it is? Oh, come on, I know you can hear me. Mike. What day is it, Mike? Leslie, guess what today is?
It's hump day.
Woo woo!
Ronnie, how happy are folks who save hundreds of dollars switching to Geico? I'd say happier than a camel on Wednesday.
Hump day!
Get happy. Get
Yeah!
Geico. 15 minutes could save you 15% or more.
Alright, now that we know what day it is, we can go ahead and continue with our distance formula. So, how could you go about finding the lengths of A, B, and C? So if we wanted to find the perimeter of this triangle, you guys probably know that much about geometry, at least perimeter, we would simply count. For A, we can count from B to C. So side A, we can count from B to C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so A is 16 units. Okay, now we have B. From A to C, 1, 2, 3, 4, 5, 6, 7, 8, 9 units. Okay. Now the issue when we get to C is where distance formula comes in. It's going to take care of it because we can't count 1, 2. It doesn't work that way. They're not evenly across the coordinate plane. What we'll learn about later on during the year is the Pythagorean theorem, which lets us take A and B, use them to find C. It's very simple, very easy, very easy, not easiest. You've probably heard it before. It's a squared plus b squared equals c squared. Again, we'll worry about that later on. For now, what we need to know is a distance formula between any 2 points. That distance formula is this. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. You will need to know that one. That will not be given to you. You'll have to know it. Okay, you're going to find the difference between the x's, square them. The difference between the y's, square them. So for this one, what we do is take this A point, -4, -6, and this B point, which is 5, 10. And we can practice right on this one. So, distance equals the square root of x2 minus x1. It doesn't matter which one's which as long as you stay consistent. So I'll say 5 minus -4 squared plus y2. So we have to go the same direction. So start with this one since we already started with 5. Make it 10 minus -6 squared. Use your parentheses. Follow your order of operations from here. D equals the square root of negative or minus a negative makes it plus a positive, so it becomes 9 squared plus minus negative plus a positive 16 squared. So we're going to have D equals the square root of 81 plus 256. So D equals the square root of 337, which is equal to or approximately 18.36 units if you round it. Okay, make sure you're able to get to that radical answer, and then if I ask, go ahead and put it in a decimal. So we're going to look at a couple of examples. Distance formula is just something you want to make sure you know you're able to use. It will come up over and over again. These take a while, so we're going to do one now, and then I'm going to have you guys do one to bring in to class tomorrow. So we want to find the perimeter of a triangle with vertices K, A, and T. Okay, so give yourself a picture. It doesn't need to be perfect with the coordinate plane, so just simply draw some sort of triangle. It doesn't even matter where K, A, and T are. It doesn't have to be correct in terms of what quadrant it would be and all that. So K is 212, A is -712, and T is 3, -8. Okay, so to find perimeter, you need all three sides. We don't have any distances of the sides. So what we're going to have to use is distance formula 3 different times. So it will take a while, but it'll give you some practice with using distance formula. So again, distance formula is right above here. We'll start with the first one. We'll find the distance between K and A. So we're going to take D equals the square root of x2 minus x1. Doesn't matter which one's which. So I'll go 2 minus negative 7 squared plus 12 minus 12 squared. And you'll like that one. D equals the square root. 2 minus a negative 7 becomes plus a positive, so it's 9 squared. Plus, this is where you'll like it, 0 squared. So if D equals the square root of 81 plus 0, so D equals the square root of 81, D is just 9. There's one distance, so here's the distance 9. Now we got another one to do. Let's go for AT next. Again, it's not very difficult, just making sure you can plug into the formula. D equals the square root of x2 minus x1, so I'll go 3 minus negative 7 squared plus negative 8 minus 12 squared. Again, make sure you stay consistent when you do those subtractions. We have D equals the square root. 3 minus a negative 7 becomes plus a positive, or 10 squared, plus negative 8 minus 12 more is negative 20 squared. So we get D equals 100, that one's easy, plus negative 20 in parentheses squared, so negative 20 times negative 20 is 400. D equals the square root of 500. Just leave it like that for now. Okay, so we'll call this the square root of 500. We'll turn it into a decimal at the very end. And the last one we need to find is TK. So let's see if I can fit it in here. We have D equals the square root of, I'll go 2 minus 3 squared plus 12 minus negative 8 squared. Okay, again, 2 minus 3, then 12 minus negative 8. Stay consistent. So we have D equals the square root of negative 1 squared plus 12 minus negative 8 becomes positive 20 plus a positive. D equals, this one's not too bad, negative 1 squared is 1, positive 1, plus 400. D equals the square root of 401. Okay, so it becomes square root of 401 here. So we have our 3 perimeters. Now, to find the perimeter, the nearest hundredth, you're going to add them up. The way you do that on the calculator isn't just in one step, and I'm going to show you guys exactly how to do it. So what you'll type in on your calculator is second, and then where the x squared button is, you can see a little square root above it. That's what you're going to do, second x squared, that gets you that. 500. Let's double check and make sure that's what it was. Yep, square root of 500 plus square root, oops, wrong button, plus the square root 401 plus our nice one that came out, 9, and round to the nearest hundredth, so 51.385. Look at that third term, because hundredths is the second term, the third term is a 5, so we go ahead and round up, so it'd be 51.39 as our final perimeter. Okay. Again, example 3 is going to be the same thing, and I'm going to want you guys to be able to do that for class tomorrow. Second kind we have is a lot easier. Just making sure we're good with our radicals, because I know that was an issue on the algebra review. So the sides of a triangle are 2 radical 3, 6 radical 3, and 12 inches. Find the perimeter in inches. Leave it as an exact answer. So you're not going to use your calculator here. make sure you're not using your calculator. I don't want any decimals. So we have some sort of triangle. We have 2 radical 3 as one side, 6 radical 3 as another side, and then 12 as our third side. Find perimeter is going to be 12 plus 2 radical 3 plus 6 radical 3. Only add up what you can. 12 plus, that's like adding 2x plus 6x, it becomes 8x, or 8 radical 3 inches. And that'd be your final answer. Okay, so example 2 is not too bad. So again, make sure you go back, try example 3, which is like the one we did in example 1 here, and then try example 4, which is like what we just did in example